Welcome. My name is Martin Lippert. I work for Pivotal, and I would like to give you a brief overview and demonstration of a prototype that we implemented for Project Flight. The goal of Project Flight is to show a new kind of architecture for cloud-based developer tooling and bridging the gap between existing tooling like your desktop IDE or your command line tools and this new world of cloud-based developer tools. It's a novel approach, and I would like to show you the current prototype implementation. Therefore, I start with an existing desktop IDE like the Spring Tool Suite or Eclipse, or you can also think of IntelliJ or NetBeans, or even your TextMate editing your local files. You can continue work as before, but in addition to that, you can connect your project to Flight. This is something like Dropbox for code. So your files, they still are on your local hard drive, and you can still use your existing tools to work on those files as before. There is nothing else, nothing changed to that setting. In addition to that, you can now access your files and your projects from anywhere in the world using, for example, a browser IDE. In this case, it's a very simple editor that runs on top of this new architecture. So this editor allows you to edit your files. In this case, it's a Java class called Home Controller. The interesting thing in this new architecture is that behind the scenes, those files are synced in the cloud. So the editor can access its own copy of that file, but other, let's say, services that are running in the cloud, they can access those files as well. In this case, there is a tiny little service running in the cloud that helps me working with Java code and does reconciling for me. So whenever I change my code inside my browser IDE here, the service running in the cloud does reconciling. So it listens to those services, does reconciling, and sends back the results on a message bus back to my browser editor so that the browser editor can show me warnings and errors, for example. In this case, it's real Java reconciling that happens here in the background. So it's no fake, it's not implemented in JavaScript in my web editor. It is a cloud service that's running in the background somewhere. And this cloud service says, oh yeah, I'm interested in Java, so whenever you change a Java file, I can help you, I can give you information back about this Java file. In the same sense, there could be other services implemented that are running independent of even the reconciling service in the cloud. For example, a service that say, oh yeah, I can give you content assist for Java. In this case, the editor sends out a message saying, oh, I need content assist, and if there's a service available that can give you content assist for Java for this file, because it has this file synced locally, it can give you content assist. That's what we implemented as well as a prototype. So there's a service running in the cloud that gives you real content assist for Java. That's again no fake, it's real content assist for Java, and you can work with that as within your, for example, desktop IDE. Another service, just to show the basic principle, is navigation. So you would like to jump to the declaration of date. In this case, you press a button and then you jump to the declaration. It's again the same thing. There's a service running in the cloud that can do navigation for you. So the editor sends out a message to the cloud, I need navigation, and gets back the result. You could do even refactoring, like rename in file with these mechanisms. For example, if I press another keystroke, there's a service telling me what places in this file, what text areas to change when I would like to rename a certain identifier, so I can refactor this variable, for example, using a service that's running in the cloud. An interesting effect of this is that those services, they can not only send me back information about this one file that I'm editing, but also about information about other files. For example, this class implements a test interface. So I navigate to this test interface. For example, let me quickly change that here. I do foo2, I press save, and then I go back to Home Controller, and Home Controller is also changed. So it got a new warning say Home Controller needs to implement this new method. That works even if I open up a different browser tab. So if I have a different browser tab open, I delete that, I press save, I go back to the other one, the error is gone, because the reconciling and compilation services running in the cloud can do that for me and sends me back, oh, this error is gone in this case. The interesting fact about the underlying architecture is that those services that are running in the cloud, they can do anything for me. They could, for example, also kick off unit tests for me. They could commit changes back to a Git repository, for example, or they can do certain services just for certain projects. In this case, for example, it's a Java project, so there's a Java reconciling or compilation service that's running in the cloud for a different project, or maybe for the same project, but for a Groovy file. There could be a Groovy service running in the cloud giving me back information about Groovy. Same for JavaScript, or the same for Scala, or for any language that you can think of. Same for Content Assist. There's maybe a very special service that can compute in the cloud with some kind of heavy computation the best Content Assist that you can think of and give me back that information directly into my editor. Those changes are, of course, always synced back to the cloud, and therefore if I, for example, switch back to my Eclipse IDE, I see that this is changed in my Eclipse IDE as well. So when I go back to my desktop IDE, because I would like to continue to use my desktop IDE after I use the browser stuff, I can still use my desktop IDE as before, because things are synced back to my desktop IDE. So let me fix it here and let me press save. So that's saved back. Of course, you could also think about doing simultaneous editing in this case. For example, if I open the same file in a different browser tab for someone else, and I change this file in this browser tab, it's also changed in this one, right? So this is the basic idea of simultaneous collaborative editing. The basic idea about this project is first to have my project synced locally, so that when you are working on the same projects maybe, you have your project synced to your cloud, so that we are not editing the same file at the same time always, in all cases. But if I would like to share my editing session with you, I could send you my URL and you can edit the files or take a look at the files that I'm editing at the moment. Oops. Okay. Send the file, save the file. Let's discard that editor and close that one. This gives you a brief overview about the basic underlying idea about this project, and shows you, I think, the power behind this idea and behind this architecture, because those cloud services, they can do basically anything they want. For example, one of those cloud services could also act as a repository and as some kind of a source of projects, for example, connecting to GitHub, right? So instead of syncing your stuff manually from your desktop IDE, you could just open up the web browser and say, okay, I would like to edit my projects at GitHub using a web interface. And services in the cloud, can still do reconciling or content assist for me, because they know how to work on Java files or Groovy files or Maven projects, for example. Okay, thank you very much. That was the quick and brief overview about Project Flight. There's a lot more to come, of course, and we are trying to collaborate with a lot of people to turn this prototype project into a real project and moving towards cloud-based developer tooling. Thank you.